Hello everyone, this is Mr. McMillan and I'm here with an instructional video. This time we're going over some additional examples for interior and exterior angles and polygons, just so we can be sure that you can do the worksheet that is posted, because a lot of these problems are similar to the ones that are posted online. So let's look at number one. What is the sum of the interior angles of a convex polygon with 35 sides? So as always, we have to ask ourselves what we want to find in the problem. And in number one, it says, what is the sum of the interior angles? So what is the sum of the interior angles? So in order to find the sum of the interior angles, we have to use the appropriate formula. If you remember from the notes, your formula for the sum of the interior angles is equal to 180 degrees times n minus 2. Or you could say n minus 2 times 180. Either way, it works. Okay? Now, to find the sum, we need to know n. And remember that n is the number of sides. Well, in our problem, it says of a convex polygon with 35 sides. So n is equal to 35, because it straight up tells us they have 35 sides. So our sum is equal to 180 times n, which is 35, minus 2. So our sum is 180 times 33. And if we type that in our calculator, 180 times 33, my numlock isn't on. 180 times 33 gives us 5,940 degrees. Number two, what is the sum of the exterior angles of a convex polygon with 150 sides? So this time it wants us to determine the sum of the exterior angles. And for the sum of the exterior angles, the only thing we're going to be doing here is, well, we know that the sum of the exterior angles is always the same regardless of how many sides. And the sum of the exterior angles is always equal to 360 degrees. It does not matter if that says 150 sides, or if it said 200 sides, or 4 sides, or 565 sides, or so on and so forth. The sum of the exterior angles is always equal to 360 degrees. So let's look at number three. Number three says, what is the sum of the interior angles of a convex octagon? So I want you to try that one on your own, pause the video, and then come back. So number three, we want to know the sum of the interior angles of a convex octagon. Okay, so since we want to find the sum of the interior angles, we're going to be using sum equals n minus 2 times 180. And it's talking about an octagon. And an octa means 8. Think of an octopus. So our n is equal to 8 in this case. So n minus 2 times 180. So this gives us 8 minus 2 times 180. 8 minus 2 is 6. Then 6 times 180 gives you 1,080 degrees. So the sum of the interior angles of a convex octagon is 1,080 degrees. All right, number four, you can try number four on your own as well. Just make sure you read what the problem wants from you first. So number four, what is the measure of an interior angle of a regular pentagon? So the measure of an interior angle of a regular pentagon. So this time, instead of finding the sum, we want to find a single interior angle of a pentagon. Now, to do this, most people decide that they want to find the sum first and then divide, and that's fine with me. So one interior angle is the sum of the interiors divided by the number of sides, which is just n. So what is the sum of the interior angles of a pentagon? Well, we're going to plug it into our formula. A pentagon has 5 sides. So the sum is going to be equal to 5 minus 2 times 180. 5 minus 2 is 3 times 180 gives us 540 degrees. So our sum of the interiors for a pentagon is 540. So to find the one interior angle, we need to take our sum, which is 540, and then divide by the number of sides. And in this case, the number of sides is 5. So 540 divided by 5 ends up giving us 108 degrees. So that is the measure of our one interior angle of a regular pentagon. The process would be the same regardless of how many sides the polygon has, as long as it's a regular polygon. All right, number 5. Number 5 says, what is the measure of an exterior angle of a regular hexagon? So you can try this one out for yourself as well. It's something that we covered during the previous lesson. So number 5 says you want to find the measure of an exterior angle. So you don't want to find the sum, you want to find just one. Well, the formula for that is exterior angle equals the sum of the exterior angles divided by the number of sides. And as we said before, the sum of the exterior angles is always 360 degrees. So that means that the exterior angle is equal to the 360 degrees divided by n. So the question remains, what is the number of sides in this problem? Well, if we look here, we see that it's a regular hexagon. And a hexagon has 6 sides. So our exterior angle of a hexagon is going to be equal to 360 divided by 6, which is 60 degrees. All right, number 6. Number 6 says one exterior angle of a regular polygon measures 36 degrees. What is the measure of one interior angle? So we're given an exterior angle to be 36 degrees, and we want to know the interior angle. Now, we talked about this a bit when we talked about exterior angles, and we found that exterior angles and interior angles had a property, for the relationship. And the way that exterior and interior angles were related is that exterior and interior angles form a linear pair. They form a linear pair when they're paired together. And since it forms a linear pair, we know that they are supplementary. And if you remember, supplementary means they sum to 180 degrees. So your interior plus your exterior is equal to 180. Well, we know what the exterior is, and we want to find the interior. So to find the interior, we take 180 and subtract our exterior, which is 36, and that gives us 144 degrees. Number 7, the sum of the interior angles of a convex polygon is 7,380 degrees. How many sides does the polygon have? So this is a bit of a shift, okay? This time it already gives us what the sum of the interior angles is, okay? And now it wants us to know the number of sides of a polygon. Typically we do it the other way. So we know we're going to have to use the sum of the interior angles in some way to find the sides. And our formula for that was n minus 2 times 180 degrees. Well, I know what the sum is. It tells me in the problem 7,380 is our sum. So 7,380 degrees is equal to n minus 2 times 180. And we don't know what n is. We want to find the number of sides. So we want to find n. And there are two ways that you could solve this problem. And I'll show you both ways, and you can pick which way you want to do it. The first one I'm going to do is I'm going to divide this by 180 first and solve it that way. So when you do that, you can divide by 180 to get rid of it. And when you take 7,380 and divide it by 180, you get 41. So on the left side, you get 41 equals n minus 2. So to solve that, you would add 2 to both sides, and you get that n is equal to 43. Now, the other way you could solve that, you could have distributed the 180 instead. And when you distribute it, you would end up getting 180n minus 360. You would add 360 to both sides, which would give you 7740. And then you could divide by 180 after that, and you would get n equals 43 as well, as we can see there. So either way you want to solve it, I don't care. You can solve it whichever way, okay? I'm going to be solving it using this method here, dividing by 180. You can use the distributed method if you choose to do so. All right, now let's look at number 8. So number 8 says one interior angle of a convex polygon measures 170 degrees. How many sides does the polygon have? Now, we could do this two different ways. Now, I'm going to do it one way. And it's going to be, this should say regular convex, but it is what it is. So I'm going to use the exterior angle instead of the interior angle, okay? Because it has a little bit of a simpler formula. So one interior angle measures 170 degrees. So just like we talked about number 6, interior angles and exterior angles are supplementary, which means they add to 180. So to find the exterior angle, we take 180 and subtract our interior angle, which in this case is 170. So we take 180 minus 170 and we get 10 degrees. So how many sides does the polygon have? You may be asking, how does that help us? Well, the formula to find one exterior angle is given as exterior equals 360 divided by n. And in this case, we know what our exterior angle is. It's 10, and that would be equal to 360 over n. Now, we have a fraction on that right side. If I want to solve this, I could just multiply both sides by n, or you could make it to where the left side is a fraction as well. So if we divide the 10 by 1, we make the left side into the fraction. And now we can cross multiply. So we can cross multiply. And when we cross multiply, we get 10 times n, which is just 10n. And we get 360 times 1, which is 360. All right, now we have 10 times n. To get rid of the 10, we have to do the opposite of multiplication, which is division. So we're going to divide both sides by 10, and we get that n is equal to 36. So n is equal to 36. So try numbers 9 and 10. They're very similar to 7 and 8. 10 has a little bit different wording, so you need to make sure you pay attention to what you have. So try those out, pause the video, come back to them. All right, number 9. Number 9 says the sum of the interior angles of a convex polygon is 4,320 degrees. How many sides does the polygon have? So it gives us the sum to be 4,320. So we know we're going to have to use the sum equals n minus 2 times 180. Our sum is 4,320. And that's equal to n minus 2 times 180. I'm going to solve it by dividing by 180 first, which we can do. So we're going to divide both sides by 180. And if you take 4,320 divided by 180, you get 24 equal to n minus 2. Add 2 to both sides, and you get that n is equal to 26. And number 10, a regular polygon has an exterior angle measuring 5 degrees. How many sides does the polygon have? So unlike in number 8 where it gave us an interior angle, this time it already gives us the exterior angle. So we know the formula for finding one exterior angle is 360 divided by n. Our exterior angle is 5 degrees. So 5 is equal to 360 over n. We place the 5 over 1 and then cross multiply. So we get 5 times n, which is 5n, equals 360 times 1, which is 360. Divide both sides by 5, and we get that n is equal to 72. All right, the back page here, 11 through 14. These are mostly images. So number 11, it says in the diagram below, what are the values of x and y? And this should be, this is a regular shape, okay? So all the angles are the same, all the sides are the same. So the first thing is we notice that we have x and y here, and after we extend the side, we see that they both lie on the same line. One of these is exterior and one of these is interior. So x is the exterior angle, and y is the interior. Now this is a regular polygon, so you can find either one you want first. Doesn't matter. I'm going to find x first because it's a little bit easier. Either way, you're going to find the other one the exact same way. Okay, so let's find x. X is exterior and it's a single exterior angle. So we know that x would have to be equal to 360 divided by n, which in this case, we have x equals 360 divided by n, which is the number of sides, 1, 2, 3, 4, 5, 6 sides. And then if we take 360 divided by 6, we get 60 for our exterior angle. Now, y is the interior angle that's paired with that exterior angle. So we said that interior angles and exterior angles are supplementary. That means that to find y, we can do y equals 180 minus 60, which is 120. So x equals 60, y equals 120. And I'm just going to show you that you could have done it the reverse way. So y would equal the sum divided by n of the interiors. So you would have 6 minus 2 times 180 divided by 6. So that would be 4 times 180 over 6, which is 720 divided by 6. So y would be 120. So either way that you wanted to do that would have been fine. All right, let's look at number 12. Now, number 12 is a familiar problem in a very unfamiliar form. So it says the following figure is a regular decagon. What is the measure of angle RST? So the first thing is it wants us to find the measure of angle RST. And RST is right here. It's that angle there. And you'll notice that that angle is an interior angle. And we only want that one. So if we only want that one, we need to use our one interior angle formula, okay? So you can find the sum and then divide by n, or however you decide to do it. What is n in this case? Well, it says this is a regular decagon. And deca, think of a decade's 10 years. Deca means 10. So in order to find RST, you can find the sum and then divide by the number of sides. So let's do that. So the measure of angle RST would be equal to n minus 2 times 180, because that's the sum, then divided by n. Well, n minus 2 would be 10 minus 2 times 180, and then over 10. So this will give you 8 times 180 over 10, which will be 1440 over 10, which is 144 degrees. And you can verify all of that in the calculator. I just have to go through it a little bit quicker. And in fact, any of these angles would have been 144 as well, because they're all congruent. All right, number 13. Using the diagram below, what is the measure of angle 5? So if you look at angle 5 here, angle 5 is an exterior angle. So we're going to have to use something involving exterior angles to do this. But here's the problem. This is not a regular shape, so we cannot use the formula we would normally use. However, we do know that the sum of the exterior angles is always 360 degrees. So if we know all of the exterior angles, we can find what angle 5 is. And the only one we're missing is this one, but since this is a 90-degree angle, we can find out pretty easily that that would be 90 degrees. So the sum of the exterior has to equal 360. So we know that angle 5 would be equal to 360 minus the sum of the rest of these. So the measure of angle 5 would be 360 minus 53 minus 88 minus 90 minus 62. And if we type that in our calculator, we get 67 degrees for the measure of angle 5. All right, and then our last one here, number 14 in the hexagon below, what is the value of y? Now you'll notice that there are two different values that we do not know. We don't know y, but we also don't know x. However, we do know that there's an exterior angle here, 27 degrees. So we can go ahead and find x. And to find x, we know that this interior angle and x would be supplementary. They're on the same line. They form a linear pair. So x would have to equal 180 minus 27, which would be 153. So x is 153. Now, we can't pull the same trick we did on number 13 with the exteriors, because all of these angles we now have are interior. So we would first need to figure out what the sum of the interiors should be. So let's figure that out. So the sum is equal to n minus 2 times 180. What is our n in this case? Well, it says in the hexagon below, we're going to count just to make sure. So 1, 2, 3, 4, 5, 6. It's not lying to us. So the number of sides is 6. So we plug that in. We get 4 times 180, which is 720. So we know that all of those angles in there in the interior need to add up to 720 degrees. So in order to find y, we can subtract all of those angles from 720, and that's what we're going to do. So we take 720 and subtract 91, subtract 153, subtract 77, subtract 134, and subtract 168. Now you could go ahead and just add all the ones you do know and then subtract them all in bulk. I'm just writing it out to show you. And so when you do that, 720 minus 91, minus 153, minus 77, minus 134, minus 168 gives you 97 degrees. So that means that y is equal to 97. And that does it for this video, guys. I hope this helps as you go to do that worksheet. If you have any questions about that, please email me, let me know. Mr. Thompson and I both do, provide extra help in the Zoom sessions, everything else. We both hold one at 2:30, so please come join us if you need help with any concepts. We'll help you out with anything you need. All right, thanks guys, and I will see you in the next video.